So in this reaction, we are given a double bond, and that's a sure sign that we're going to be doing an addition reaction. That the extra electrons in that pi bond are like extramolecular glue that we can use to add things onto this carbon chain. What we're going to add depends on what we're mixing with that double bond. And so you would want to see this halogen, Br2, and water, H2O, as the recipe for a halohydrin formation. So you would know that because you would have studied the reactions, the addition reactions for this chapter enough to recognize that recipe. And what we're really interested in when you do each of these reactions is what you're adding, where you're adding it, and how, in what direction you're adding it from. So what you add when you do halohydrin formation is a halogen. In this case, the halogen they're giving us is bromine, but if it were Cl2, then it would be chlorine. But they give us Br2, so we're going to add bromine. And the other thing we're going to add is OH. Now that's ultimately coming from water. Water adds in this reaction, hence the hydro in the name. And after it adds, you just do a proton transfer to remove an H+. So the H2O becomes an OH. So those are the two things you add in halohydrin formation. One thing you have to be aware of is that the OH goes to the more substituted carbon. In the mechanism, the bromine adds first, and you form a carbocation on the more stable position, the more substituted position. So the bromine adds to the less substituted position. And so over the course of the mechanism, the OH adds to the more substituted carbon where the carbocation was. So the bromine adds first to the less substituted position, and that means the water, or the OH, is going to add to the more substituted position. Finally, this is anti-addition. So if the bromine is going away from you, then the OH will be coming out at you. Or if the bromine is coming out at you, then the OH will be going away from you. That's what it means for this to be anti. And if you have a chiral center, just be sure to draw both enantiomers. Because the original molecule is flat. These carbons in the double bond are trigonal planar. They're sp2 hybridized and trigonal planar, so they're flat. And so the reaction can happen with equal likelihood from both directions. And so you end up getting both enantiomers when you do the reaction. Okay, so let's apply those ideas to this specific molecule. You're going to look at the two carbons in the double bond. Now there's no rearrangement in this reaction, so the two things we're adding will always be on the two carbons that are in the double bond. The OH goes to the more substituted carbon. Now you'll notice the carbon on the left here is bonded to two other carbons, so it's secondary. And the carbon on the right is bonded to 1, 2, 3 other carbons, so it is tertiary. Now the OH goes to the more substituted carbon. So the OH is going to go to this tertiary carbon here. And that means the Br, or the halogen, is going to go to the less substituted carbon, the secondary one there. Now as we add those things on, we use up that molecular glue that was in the pi bond, so we erase that pi bond. That won't be there anymore. And we do have chiral centers here, so we're going to need to draw both enantiomers. And we're going to have to make sure that both of these groups are anti to each other. So in one enantiomer, the bromine will be going away, and the OH will be coming out at us. In the other enantiomer, the bromine will be coming out at us, and the OH will be going away. And that would be the final product, except we have a tetrahedral carbon here, and tetrahedral carbons need to have two bonds in the plane, one coming out at you, and one going away. So if this bond to the OH is coming out at us, that means the bond to the other branch needs to be going away, to show that that carbon is tetrahedral. Similarly, if the OH is going away, then this tetrahedral carbon needs to have a bond coming out. And so that can be to that other branch there, that isopropyl branch. And so you get these as your two final products. You get both of these products equal in equal amounts. And if you want, you can make that all the same color. And so those are your two final products for this halohydrin formation addition reaction.